This is an important panel which looks at a huge amount of tech, but I'll try my best not to bore you, not get into too much of jargon. A quick one, Vikram is the boss of Neuralix AI, doing a lot of work for the armed forces. Sunil is the director of Semiconductor Futures Accelerator Lab, which is run by the government of Karnataka, one of the most important incubators of semiconductor design ecosystem in the country. Companies like Sankhya Labs, Tejas, Caligo have all come out of SFAL, by the way. Then, of course, we have Amit. He comes from the DGIS. He looks after the AI vertical. Then, of course, Colonel Pillay is known very well. He's a researcher, author. His book is coming out very soon. And he's one of the best minds insofar as, military history is concerned in India, and writes exclusively on AI ethics. And of course, then we have Dr. Pradip Thaker. He's been the head of Marvell Semiconductors in India. Now he looks at D-Matrix. He's heading D-Matrix, which looks at a huge amount of AI processors, and a lot of work is being done by him in terms of AI, in terms of tech. So what I'll do is, since the clock is ticking and I don't want to bore you, what we'll do is we'll have a freewheeling discussion. Nobody needs to go anywhere. We'll just ask a couple of important questions. Look at what is required for the armed forces. Where are the gaps, this, that, and the other? And then we get on with what are the solutions to the whole thing. So let me start with you, Dr. Pradip. Firstly, let me ask you very clearly, what is the impact of AI on the, a lot of has been taught about the Observe, Orient, Decide and Act OODA loop. And, we are all aware of what is NGCC 2. So what do you think is going to be the impact of AI on both these issues, and especially when they concern the military?
Thank you, Colonel Awasthi. Very honored to have to be part of this conversation. Thank you for the opportunity. The impact of AI in the nation's sovereignty and security is analogous to the days when gunpowder and cannons were invented, and North American civilization, basically that was used to spears and swords, fell and doesn't survive anymore. I think the AI and semiconductor are two key technologies where we as a nation need to really establish significant leadership over our competition. And particularly for AI, we have two aspects of AI, and both are important. One, what we usually refer to as the edge AI, and second one, what we refer to as a cloud computing AI. When we build the military structure on all domains, whether it is terrestrial, in the marine, or in the air, there is tons of information that needs to be pre-processed and trained, and all of that work happens on the cloud computing with very complex, very large models. And the intelligence is gathered, it's preserved, it's updated on regular basis. And when we send the operation in the field in form of drone or in form of underwater equipment, etc., or robotics on the ground, that makes a use of edge AI. And edge AI really runs on very complex algorithms that process real-time information that it derives through sensors. And the information that comes real time through the sensors, portion of it needs to be processed on the edge, and decisions need to be made autonomously. Some information is fed before the end device, like a drone, takes off from the base station information, where there is a pre-programmed information available. So from the AI perspective, I think as a nation, we have a lot of excitement building up around both forms of AI, the edge AI as well as with the cloud computing AI. But we have a long way to go to really compete with the capabilities that the other nations like China or US, particularly what you saw what happened with Fable and Mythos. I think we have a long way to go and a very short time to cover the distance.
From there, what you just mentioned about all these things, what is happening is somewhere down the line, some priorities are also changing. How they're changing is, it was an era of DRAM at some stage in time. Then the era of, memory chips gotten into place. While I don't discount both of them. But now I think the focus now is on power electronics. It's on power management. So that also possibly could be factored into the whole bigger picture when, especially all the services are here. They have to understand that part, that, power electronics is going to be the key. The lesser the power they actually consume, they give the lesser signature, the less amount of cooling they require, a huge amount of things, and the form factors can become smaller at times to go. So Sunil, you are the director at Semiconductor Fabless Accelerator Lab, So while we speak about this power electronics and we speak about power management, which is going to be the biggest, bugbear. So what do you think with these new materials coming in with gallium nitride, silicon carbide, etc., how do you think the design ecosystem is now going to go and undergo a change?
Yeah, I think, of course, power is becoming an important aspect, especially for strategic and critical applications. Because the performance of the semiconductor also needs to be capable of circumstances which are different from a civilian kind of requirement or a commercial requirement. Fundamentally, there is no structural change in the way design is going to get done. But I think today we have the advantage of leveraging some of our homegrown capabilities, whether it is GATEC, which is basically working on a foundry for gallium nitride, or SPSS, which is working on let us say silicon carbide and gallium nitride technology. So for a designer in India, there's an opportunity for us to leverage these existing assets or infrastructure to start designing for this strategic sector, or also starting to innovate on power electronics. I think that is the new change that is coming in. Additionally, also because of the growing market in India, whether it's in automotive space or even in industrial space, in industrial sector, we are seeing an opportunity for indigenous power electronics designs, both at the chipset level and also at the module level. So that's the trend.
That's the trend. That's correct. So if that is the trend, Amit, I come to you now. If that is the trend and that is what the AI system wants to say and all of that, so how is the Indian Army now leveraging AI between the command and control systems? This is a very major requirement today, and we've all spoken about, data sets, data management, etc. But how are you leveraging AI in the command and control systems in the short term, medium term, and long term?
First of all, I was happy to hear what the CDS initially mentioned in his opening address. And whatever were the problem areas which he said, I'm happy to state that I think we are on the right track. The journey of AI into the Indian Army started about 2 years back in total essence as such. And what we started and where we are, if I talk about the CDS point of views, the first and foremost, he talked about the data collection. So as far as data collection is concerned, there are applications within our Indian Army, and very soon these applications are going to be hosted on the Tri-Services architecture. That is a joint communication architecture by the name of Avlokan, which is a data labeling and annotation tool which we have already given to all the commands, and the process as we speak is already ongoing. And it's a huge number of data sets, specifically from our own as well as the adversarial point of view, that we have been able to annotate this data. Now this requirement came from the industry itself, that they needed data to work on, and therefore this data is now ready with us. And under the aegis of ADB, whosoever is the industry partner selected, they can come and work on-prem with us as far as using this data for your drone feeds, auto detection using the drones or whatever sensors are being deployed in the forward edges. Secondly, as he correctly brought about, was the data existing in silos. Yes, it was a huge wall to break, and finally we have people like Jangai and others who followed this step of breaking down this data, and now we are in the process of sharing huge amount of data within our own organization, as also very soon we will have in the Tri-Services also. The data which we have collected, which was a major exercise carried about last 6 months, we have collected about 605 GB of data, and which we used for training of our military LLM, which I'm going to speak next. As far as common data standards are concerned, I beg to differ with the CDS there, because we do have the APIs and the MCP protocol today, and we don't need any common data formats as such. These The data can reside in any which fashion which are there, and the data points can be decided, and they are being decided. And we do have our Indian Army API portal on which we decide which data sets to be exchanged between various applications. And soon this, Indian Army portal is also going to be used for the tri-services, data integration. Now coming to the digitization part of this journey, which we started about 1.5 years back. As a pilot case, we did it for 2 of the brigades here in Delhi. We are proud to say that they are all completely digitalized as of today, with the AI and the compute available at the brigade itself. This pilot project, now we intend taking pan-army, maybe one command first, and thereafter going pan-army, so that the data digitalization happens. Notwithstanding that, we did have a ACOM AI platform, which was ACOM AI as a service platform, which we hosted last year, inaugurated by the Raksha Mantri. And we have created data containers for all the line directorates and various other, command headquarters, maybe in the domain of intelligence, operational logistics, and even in ops now. And we are in touch with the MO directorate as far as their data digitalization is concerned. What we inaugurated was ACOM AI as a service platform, which will now further, delve into. And before I came here, we were here with Mr. Dr. Vikram here. We are also going into the knowledge graphs, doing deep research, analysis as far as a normal military LLM is concerned, which will have these features also. The most important thing which we intend going thereafter is the data lakehouse. The work is already on. The RFP is due anytime now. And this is the data lakehouse, which has been told by the headquarter ideas to first have it at the service specific level. That is the data lakehouse for the Army, for the Navy, and for the Air Force. And thereafter have a tri-services data lakehouse. The RFP is already ready, and we are soon going to have this data lakehouse where all the data is going to flow from everywhere. Now, as far as the LLMs are concerned, which is at the edge, as well as at the central. So LLMs are there, which are right now open source. But as we speak today, we just witnessed our own military LLM, which we started about 1.5 years back. We have built a 3 billion parameter model from scratch, trained on military data. Intend to take it to 10 billion parameter by the October timeframe, and in near future we will take it to 100 billion parameter models. So these are some of the initiatives which we have taken. Some of the other things which we can discuss about are also the CPU-based SLMs, just a second, which will be there as part of the ecosystem for the edge devices also. And for the decision support system, if time permits, I can undertake the various decision support systems which we are undertaking.
Thanks, Amit. Let me come down to Vikram. Vikram, what does Neuralix AI do to begin with? And the second part is, as a lot of things have been said since morning, as AI moves from assisting commanders to influencing targeting and command and control decisions. We've all been speaking about that. So where does the industry draw this line? Now there's a very important, it's a very important and a nuanced question that I'm asking you. At some stage in time, you have to understand the industry also has to draw a line. So where does this draw this line?
Thank you, first of all, Col Awasthi, for this esteemed panel and for having me here. So Neuralix AI is an engineering-first AI-augmented company. So we believe a lot in engineering principles at the first place. First principles, applying it in variety of different domains, especially in decision support systems. So we work with industries, manufacturing, defense, and more importantly, the energy sectors. Now, I don't think the line should be drawn at human in the loop. That phrase has a false sense of comfort. The real question is, does the human still have meaningful judgment to do? And that is very important. An army personnel can technically, in the loop, can take more than 200 AI-generated decisions at a time, recommendations that are coming in. And under enormous time pressure, the effective they can become is in approving those which the machine has already done it. So the question is, from an industry perspective, I would draw a line in terms of authority, accountability, and reversibility. And that's where it matters the most.
Authority, accountability, and reversibility. Great, fine. So that's a great three-tiered process. Okay, so taking off from that, I come down to Colonel Pillay. He's talked about accountability, reversibility, and the authority. These are the three major things. Now, when the command and control architecture that we are talking about is moving at some machine speed, and you just mentioned, sir. Now, there's a severe risk of automation bias. You write a huge amount of pieces on ethics in AI, sir. Now, in this case, it also can happen that a human becomes just a rubber stamp. Just TK. That's the way it is. So how do you tackle this, sir?
This is a very important subject, and I'd like to say that I've just taken out a book on this, ethics on AI. And this question, like I just saw this movie called Odyssey yesterday. And in that, if you see Christopher Nolan's movie where Odysseus talks in the end that we turned the sacred art of hospitality, where they left a gift to them and we weaponized it. So this question of ethics in warfare, which is something that, it's not something that is coming new to us because the warfare has changed space or whatever, because like he mentioned just now, from bows and arrows, and we've heard about what the CDS said and General Shingle said, that from when we joined the army and what the ops room is like a Star Wars room. So what has happened from the shooter to the sensor, today we are on one grid. What you see is what is actually happening. So these things have compressed it, and this issue of ethics in warfare has confronted us from times immemorial. Like if he talks about the Mahabharata, where the Brahmastra was unleashed and Ashwatthama was incapable of recalling it back. So, and he's penalized forever for having violated a human. So the thing about the human race is that though they talk about military victories, but there's a lot of thing about ethics. So if you see World War II, what happened? Or World War I, chemical weapons that were used in large numbers, and then 1925, the Chemical Weapons Convention came, they ceased to be used. Thereafter, what we saw in World War II is, the use of atom bomb and the others. So this ethics has to be driven into those models, which is definitely is what the systems need to be evolved. What has happened today is that you have this OODA loop, that famous what we talked about: observe, orient, decide, and act. So what happens is now you just observe and act because of the rubber stamping that happens with a person. So I think the systems need to be created in a such that they can actually help the commander orient himself. Not just observe and to an action, and the decision has to vest with him. Those algorithms that have to be created, or this thing that aids a person, has to be actually in.
Well brought out, sir. Now coming back to you, Pradip. We've been together in the semiconductor ecosystem for more than 4 years. You and me. We've seen the metamorphosis taking place from ground zero when the India semiconductor mission came into being in December 2022. So there are some foundational chip technologies which will only support cutting edge AI capability. That we are quite clear. Could you just enumerate this, because a lot of service officers need to understand this?
When we talk about complex algorithms, thank you. When we talk about complex algorithms and AI, it's all really built on a hardware platform. So when we used to talk about programming or IT, it happens on a computer. Similarly, all the software and its all capabilities run on the hardware that's built. And if we say any sovereign country, to remain sovereign, it will need sovereignty on the advanced high-tech semiconductor technology, and it will require sovereign AI. These are the two key ingredients for any nation now, from here on out till something new like AI arrives in future. Having said that, the requirements for the edge AI, where the technology that gets deployed into, say, drones or underwater UAVs or such, has very different requirements than what gets deployed into cloud computing for AI. When you send a vehicle out that is unmanned, you need to be able to run it battery operated. Therefore, it must have the minimum amount of, it should have ultra power dissipation or ultra low energy requirements. The second thing that happens when the UAV is out there reacting to real-time information that it is gathering, and it has to make certain decisions on time, it does need to stay connected to the base station. And that communication, if it's broken, it's end of the game for that particular piece of the UAV. So that's where the ability to be able to run into the wideband channels of communication, where it gets extremely difficult for a hostile penetration and breakdown of the communication. So that's where gallium nitride technology plays a very important role. It's a semiconductor material. It is very different than silicon. What we generally talk about chips these days is in the commercial sector. It's primarily VLSI chips that are built using silicon technology. But for the UAVs or for the end operator, for the edge AI to function, gallium nitride is the technology that we need to have. Government of India has some initiatives that has been kicked off for quite some time, and we are making good progress there, but we are not, again, quite there to deploy it effectively. Similarly, when we talk about the command center, which is stationary, where there is a lot of intelligence is pre-processed, that is where we require, again, a very high performance capabilities. And performance capabilities in VLSI technology generally comes from going to more and more advanced nodes like 3 nanometer and 2 nanometer and such. So currently, most of our focus in the initiatives that we have with semiconductor manufacturing in the country are driven on the commercial aspects to be a global hub for supply chain. And we manufacture those process nodes where we see good revenue sources, such as 28 nanometer, right? In addition to that, when we are deploying our semiconductor or electronics technology in the field, it does need to have something that's called radiation hardening, depending upon the level at which it's flying. So that's an additional complexity in the silicon process that normally doesn't have. So if I were to just summarize, right? So in a short summary, I think gallium nitride for supporting edge AI deployment live in the field is extremely important for our nation's security. And we need to invest more and progress more and progress faster. Radiation hardening process needs to be brought in for any kind of chips that we are going to make for our nation, for our national security in the country. And thirdly, we do need to push our own R&D research. That anything below 6 nanometer and below, those technologies are not going to be commercially available to us. We will not be able to purchase and deploy. That's something we will have to invent. And we do have some very advanced research going on, for example, with the IISc, with Nanosciences Lab, IITs, IIT Delhi, IIT Mumbai and such. And I think we'll need to ensure that we get that capability ourselves developed to play into advanced process nodes, which will then result into supporting manufacturing of AI chips for the data center cloud computing. And the last point is packaging technology. So packaging technologies, now the latest one, they are called 3D, three-dimensional technology, or heterogeneous integration. These are the two names used, but it's the same thing. But what it allows now is to actually combine gallium arsenide as well as silicon-based technology, right? So now you can mix and match in what you deploy in the field. What is performance intensive, we could do it in silicon technology. What is power intensive and require that additional electromagnetic field resistance can be done in gallium nitride, and both can be put in the same packaging. So packaging technology, I think I've seen some of the workshops, etc., that is getting put together by various industry associations in the last 2 years, and some announcement of newer companies coming up in manufacturing with packaging technologies. But 3D packaging technology, I think, is something that we need to really put a national focus on and support the growth. So that way we cover all the bases for us to be independent of our needs to home generate and home deploy.
Taking a cue from that, Sunil, let me come to you and ask you, what Dr. Thaker has said. You are in the design space of all these AI chips. Now, with AI, there's a massive impact on design, logistics, system integration, and this impact is much more than as they call fabbing chips. That I've got a fab going, and I'll fab chips. So what are your comments on that?
Yeah, firstly, I think we have been looking at AI, especially in applications such as defense. Predominantly, I think most of the talk was saying, it is all about the software. I don't think it is all just about the software, because without the chip, no matter what stack you build, you're not going to be able to run your drones. The second aspect is we also talked about data centers. Whether you have structured data sets or unstructured data sets, you still need silicon, or you need basically chips to work on those, whether it is memory storage or anything else. So the impact of AI has been across, or is going to be across the value chain. Manufacturing, or even first of all, design of chips itself is changing, because now AI is able to accelerate the amount of time that is required to do validation of chips. But just a typical chip design, when it happens, almost 70% of the time is spent on validation, not the actual design part. If I'm spending 100 hours, I'm just giving you an idea, almost 70 hours is spent on validating the design. Now, AI has been automating this, and it's speeding up the process. What this will do is essentially, if you look across the world, using AI, good actors, bad actors can design chips faster. I think this morning, we had a lot of talk about, how you would respond to threats, but we are going to start having, adaptable chips. People are going to start making chips like we are making drones today, because it's cheaper to do it, faster to do it. So first impact is on the design side. Coming to front-end and manufacturing and back-end manufacturing, which is the fabrication units, as well as if you look at packaging, definitely some of the processes which are involved will be automated using AI. Inspection processes will be much better and far more accurate, which means we will have more complex chips at lesser cost, produced faster, okay, at scale. Beyond that, again, when we look at integrating these chips into systems, again, AI is going to play a role. This is just as far as the design and manufacturing is concerned, but also as far as supply chain itself. We talked about fusion. I'm talking about fusing technologies for creating chips, because chips don't come from one place. To give you a simple example, a simple memory chip, let's say being produced at Micron or somewhere, you need about 6,000 components or 6,000 suppliers to create one simple memory chip, and logic chips are far more complex. Again, the other challenge so far has been that these are pretty much protected by monopolies across the board. For example, if you take equipment, we talk about ASML, it's the big thing in the news.
Cartels, actually.
Yeah, but reality is actually, that is only for the below 10 nanometer chips where you require the latest bleeding edge. But we have got Canon, we have got Nikon, which are again Japanese, nobody talks about them. Then we have got the 5 equipment manufacturers, most of them are American, right? EDA players too, all of them are American. So we have a supply chain challenge also. But what I want to call out, I think one of the folks in the earlier panel said, we can specialize on certain things. I don't know if you know, or a lot of people may know, you may have heard about Toto, the Japanese company. It makes toilets. But did you know that without Toto, it becomes extremely hard to manufacture silicon wafers, because Toto makes ceramic plates, which is one of the only companies in the world, just one company. So they can make. Second, for those of you who hate MSG, Ajinomoto, Ajinomoto makes what is called ABF, which is Ajinomoto bonding film, which is used in every substrate of chips. And Pradip talked about stacking substrates. You cannot do it without the Ajinomoto film, right? And recently, I think 2 years ago, they had a problem with some supplier, and the entire chip industry suffered, but nobody talks about these small little things. My point is, we can innovate. I mean, the GATEX, we can have those leverage points and innovate on small little things rather than doing this. And we can use AI for logistics innovation, for innovating on new materials. So just to summarize, it is not about just AI software stack, because if, for example, we are embargoed on getting some of the AI, by the way, I don't know if Anurag introduced Pradip. Pradip now is part of a $3 billion company from zero. So, just a $3 billion AI company, which he's the engineering manager, grew from scratch. Most of the team is in India. So we can do it. So we have to find those slivers, use AI to innovate, but also understand that AI has an impact across the board. It's not all about software, because without those chips, no drone is going to fly.
Great. I think we are very short on time. The discussions can go very, very long because the topic is very vast. Anyone who wants to ask one or two questions, please, if there's anybody. Otherwise, yes, sir, please.
So I just want to understand, we have a semiconductor lab in Chandigarh, which has certain capability of building chips, or not building, or designing chips. Those chips, can they have some industrial application considering the limitations of 180 nanometer, whatever they...
That's a very good question, sir. That's a very good question.
How do we commercialize and invite the industry to make it economically viable or commercially viable?
Actually, you've taken my question. This was a question I was going to ask, but for the lack of time.
Thank
It's
you.
a very important question.
Thank you.
Yeah, first of all, I think to demystify that SEL does manufacture chips. It has been doing this for a very long time, and the strategic sector has been using that in a very capable way. The question around whether 180 nanometer and below are viable, actually they are. We talked about the 4 nanometer chips, and those are high-end applications. But a majority of day-to-day consumer applications do use 180 nanometer, and in fact, to a large extent, it is sufficient. A lot of automotive applications today operate in the 90 to 180 nanometer. Space, for example, where you require ruggedized, chipsets, I think SEL has been doing a great job. The second aspect is the government of India, as far as my understanding goes, has already opened up that fab for startups to actually tape out. I think almost 100 institutions as well as some startups have taped out, meaning they've used the SEL facility to actually create chips. So that has happened. Secondly, I think there is a $2 billion or $1 billion budget which has been allocated for refurbishing SEL to basically upgrade the capabilities of SEL. So it is definitely a national asset, and just like GATEC or anything else, we definitely would want to upgrade and leverage that, especially for strategic applications.
So when I talked about gallium nitride, that's a process and a material. Apart from that, in AI, building AI hardware, there is new types of architectures that are called chiplet architectures. And those are some other areas as a country we need to invest and grow. And the third one is a type of technology which is called neuromorphic technology, which is quite far advanced in China and other US kind of countries, which is another area. So I just wanted to summarize saying 2 types of AIs and 3 types of baseline solutions. Gallium nitride is a technology, neuromorphic architectures, and neuromorphic technology and chiplet-based architectures. Right? This is basically, I wanted to just put it out there. We can always cover that later. Thank you.
Right. Thanks. Thank you, Dr. Thaker. Thank you, Colonel Pillay. Thank you very much. But for the lack of time, Amit, thank you for giving that entire exposure of what DGIS is doing. More power to you. Sunil, keep designing well. Neuralix, you're going to be a big part of the entire system with the DGIS. I wish you luck. And thank you for a very patient hearing, ladies and gentlemen. I know it's very technical. It gets very painful at some stage in time, but let me tell you, it's very important. This is the heart of the artificial intelligence that we just talked about. Thank you very much. Have a good evening.